Tonight, we're going on a calm adventure together, floating into the story of the oceans, those huge, mysterious waters that cover most of our world and still hold more secrets than answers. This is a place for slowing down, for letting your mind wander as steady as the tide. Before we start, I'd love to know, where in the world are you listening from tonight? It's always a quiet joy to imagine this video reaching far away shores. And if you enjoy these gentle explorations, a like and a subscribe would mean a great deal. To those of you already subscribed, thank you for being part of this calm little community. Now, I do hope this video doesn't become so interesting that it keeps you wide awake. Though if it does, at least you'll drift off with a head full of new and curious things. So, as we start this story, ask yourself, what does it really mean that our world is an ocean world? The oceans are not simply bodies of water. They are the main feature of our planet. Seen from space, Earth wears a cloak of blue, so deep and huge that it is unlike any other world we know. The seas cover more than 2/3 of the planet's surface, a great shimmering area that holds almost all of its water. Yet for all their hugeness, the oceans are fragile, complex systems that breathe life into every corner of the globe. They are restless, forever in motion. Tides surge and fall, pulled by the moon's steady hand. Currents sweep across entire hemispheres, carrying heat and salt like blood through veins. Storms rise from their surfaces, reshaping coastlines and memories alike. And beneath their waves lie hidden landscapes, mountain chains taller than the Alps, trenches deeper than Everest is high, and plains stretching wider than continents. The oceans are also the memory keepers of Earth. They hold the earliest traces of life, from tiny whispers that once flickered in shallow seas to the amazing explosion of creatures that filled ancient waters 500 million years ago. They have fed empires, carried explorers, and inspired myths of gods and monsters. Even now they control the climate, soften the seasons, and keep billions of lives alive, both human and beyond. And yet they remain largely unknown. Despite centuries of sailing, science, and satellites, the deep still fights our reach. We have mapped the surface of Mars in greater detail than the floor of our own oceans. There is wonder and a little humility in knowing how much still lies beyond our grasp. This is the journey we will take tonight, from the birth of the seas on a young and fiery Earth, to the tides and currents that shape our days, to the mysteries of the deep and the stories humanity has woven around them. The oceans have many tales, and we will follow them like a current, slow and unhurried through time and across the world. So settle in, let your thoughts drift like a boat carried by the tide, and listen closely. The oceans are waiting to tell their story. 4.5 billion years ago, Earth was a place almost unrecognizable from the calm blue planet we know today. Instead of oceans stretching to the horizon, the surface was a violent and melted landscape, its skies thick with choking gases and constant firestorms of rock falling from space. It was a world in the process of being built, still gathering the materials that would one day make seas, mountains, and the fragile conditions for life. Water, the most ordinary of substances today, was at the time an alien visitor. The question of where Earth's water came from has puzzled scientists for generations. The answer, as it often is in nature, seems to be both simple and wonderfully complicated. Some of it was already locked inside the minerals of the young planet. As Earth formed, countless crashes welded smaller planetary pieces into a growing sphere, trapping unstable compounds deep within its interior. Among those compounds was hydrogen, waiting patiently to bond with oxygen. But water also came from the sky, delivered by a constant hail of comets and icy asteroids. These wandering bodies carried water frozen in their cores, and as they smashed into the infant Earth, they released it in great bursts of vapor. The chemistry of these ancient projectiles can still be read today in the isotopes of hydrogen within our oceans, faint fingerprints of their space journey. The surface of Earth in those first hundreds of millions of years was no place for a gentle swim. Imagine a world wrapped in a suffocating atmosphere of carbon dioxide, methane, and nitrogen. Volcanoes erupted endlessly, releasing steam, sulfur, and carbon. Every mountain was a furnace, every plain a lava field. If there were seas, they existed only as brief boiling pools that quickly vanished into the furnace-like heat. Then came what geologists poetically call the Late Heavy Bombardment. Around 4 billion years ago, the solar system turned into a space shooting gallery. Leftover debris from planetary formation rained down upon Earth, cratering its surface and adding yet more water, metals, and organic molecules. It was during this violent time that Earth's destiny as a water world was truly sealed. The crashes were catastrophic, reshaping the surface again and again, but they also released amazing amounts of water vapor into the atmosphere. Imagine the sky dark with dust, glowing with falling rock, while beneath it steam roared upwards from every impact. It was not a tropical beach holiday, more a boiling cauldron of chemistry, bubbling away in preparation for something extraordinary. As the bombardment slowed and the young sun settled into a steadier rhythm, Earth itself began to calm. The crust thickened, volcanic outbursts became less constant, and the global furnace started to lose its heat. Slowly, the planet cooled enough for the steam-heavy atmosphere to condense. Rain fell in torrents beyond anything our modern skies could produce, sheets of water that continued for centuries, maybe even thousands of years. The flood filled the craters and low-lying basins, carving channels and pooling into vast, restless bodies of water. This was the birth of the first oceans. Around 4 billion years ago, Earth's surface transformed from scorched rock to shimmering blue. The oceans were different then, far hotter, more acidic, and often choked with dissolved minerals that leaked from the raw new crust. Yet in their turbulence lay the foundation for everything that would follow. The scale of this transformation is hard to overstate. In a geological blink, Earth went from a hellish sphere of fire to a planet wrapped in seas. Water did what it always does. It softened, it wore away, it smoothed the jagged edges of a violent past. Ocean waves lapped against fresh volcanic islands. Tides surged across strange landscapes. And in their cycles, the oceans began to carve the earth into something recognizable. These early seas also had another role to play. They became the world's first laboratories. Within their heated shallows and mineral-rich depths, chemical reactions began to chain together, building complexity out of chaos. Though the details remain hard to understand, many scientists believe that the stage for life's first flicker was set right here in those ancient waters. And so, the oceans became more than just a feature of Earth's geography. They became its beating heart, a reservoir of memory, stretching back to the very dawn of time. Every drop of water you see today carries a story that began billions of years ago in the outgassing breath of volcanoes and the icy shards of ancient comets. To think about this is to recognize just how unlikely it all is. Out of the countless planets in our galaxy, Earth alone holds vast oceans stable for billions of years. They are the reason we call this world the blue planet. They are the medium through which continents drift, Climates change and life continues. What began as fiery vapor and relentless bombardment has become the gentle swell of tides, the quiet rhythm of waves that whisper against every shore. When you stand on a coastline today, looking out at the horizon, it is worth remembering that the water before you is unimaginably old. It is older than mountains, older than continents, older even than the very species that gazes upon it. Those waves carry with them the story of Earth's beginning, a story that began in fire, in stone, and in the endless patience of time. The oceans may appear timeless, as though they have always stretched across the same horizons, yet their very foundations are in a constant motion. Beneath the waves lies a restless engine, slowly shifting and reshaping the basins that hold the seas. This is the domain of plate tectonics, the great conveyor belts of rock that never truly rest, even if their pace is measured in centimeters per year. To imagine the oceans without plate tectonics is impossible, for it is this steady churning of Earth's crust that determines where the waters gather and how coastlines are drawn. Continents themselves drift like huge rafts carried on the flowing mantle beneath. What looks solid beneath our feet is in reality part of a grand puzzle that is forever changing its shape. The idea that continents move was once dismissed as fantasy. Early in the 20th century, Alfred Wegener proposed that today's continents were once joined together in a supercontinent called Pangaea. At the time, many geologists laughed at the suggestion. Continents, after all, seemed fixed and immovable. Yet, as evidence mounted, matching fossils on distant shores, mirrored rock formations across oceans, and the unmistakable outlines of coastlines that looked like pieces of a jigsaw puzzle, Wegener's vision began to take hold. Today, we know he was right, though the forces he imagined were only part of a much deeper and more complex story. The ocean floor itself holds the clearest record of this ceaseless motion. In the middle of the great ocean, basins run chains of volcanic mountains called mid-ocean ridges. These ridges are not quiet landmarks, but living boundaries where new crust is born. Magma rises from the mantle, hardening as it spreads outwards, pushing older crust away on either side. It is as if the earth is slowly unzipping itself with molten rock, creating new seafloor in the gap. The Mid-Atlantic Ridge, for example, snakes down the center of the Atlantic Ocean for more than 10,000 miles. Along its length, fresh basalt wells up, gradually forcing the Americas and Europe apart. If you have ever looked at a map and noticed how neatly South America seems to fit into the curve of Africa, it is because they were once joined only to be separated by this expanding seam. The process is so gradual that you will not notice it at the beach tomorrow. Yet given millions of years, oceans can open from nothing more than a rift valley into a vast expanse of water. Where crust is created, it must also be destroyed. At subduction zones, one plate slides beneath another, sinking back into the mantle where it is recycled. These are dramatic places, often marked by deep ocean trenches, such as the Mariana or Peru-Chile trenches. They are also the sites of earthquakes and explosive volcanoes, stark reminders that the boundaries of the plates are places of extraordinary energy. Entire coastlines have been shaped by these slow but relentless collisions. The Pacific Ring of Fire, with its arcs of volcanoes and frequent quakes, is the most famous example of subduction's raw power. This cycle of creation and destruction is what keeps Earth's surface dynamic. Without it, the oceans would stagnate, continents would lock in place, and the planet itself would lose much of its geological vitality. Instead, our world is constantly renewed. The ocean floor may look ancient, but in truth, it is surprisingly young. Most of it is less than 200 million years old, a blink in geological time, because older seafloor has already been swallowed into the mantle. Contrast that with the continents whose rocks can be billions of years in age, and the difference becomes striking. Through the ages, this restless movement has given rise to entire cycles of superoceans. Long before the familiar Atlantic and Pacific, Earth was home to vast water bodies with names that sound almost mythical. Panthalassa, which surrounded the supercontinent Pangaea, the Tethys, an ocean whose remnants today survive as the Mediterranean, the Black, and the Caspian Seas. These vanished oceans remind us that what we see today is only one chapter in a much longer tale. Millions of years from now, the map of the seas will once again be unrecognizable as new basins open and old ones close. The Atlantic Ocean, which feels so permanent in our modern imagination, is in truth a relative newcomer. It began as a rift splitting apart Pangaea, roughly 200 million years ago. Since then, it has been steadily widening, fed by the ceaseless birth of crust along the mid-Atlantic ridge. The Pacific, meanwhile, is shrinking as its floor plunges beneath surrounding continents. Someday, perhaps tens of millions of years hence, the Pacific may vanish entirely, leaving new continents and seas in its place. It is humbling to think of the oceans not as static features, but as temporary expressions of deeper forces. The water may remain, but the containers that hold it are continually remade. Beneath every wave lies a landscape as dramatic as any on land, filled with ridges taller than the Rockies and trenches deeper than Everest is high. Hidden from sight, the ocean floor is a canvas painted by time and pressure, written in lava and folded in stone. Modern technology has given us glimpses of this hidden world. Sonar mapping has revealed the symmetrical patterns of magnetic stripes on either side of mid-ocean ridges, alternating bands of polarity that prove the seafloor is spreading, recording Earth's magnetic reversals like a tape running endlessly forward. Satellites now detect minute changes in the ocean's surface, hinting at the mountains and valleys concealed below. Yet despite these advances, vast portions of the seafloor remain unmapped in detail, still holding their secrets. The story of ocean basins is ultimately one of balance. Plates diverge and new seas are born. Plates converge, and ancient floors are drawn back into the Earth's depths. It is a process too slow for human senses, but steady enough to sculpt the entire planet. When standing on a coastline, it is easy to believe the sea has always been there. But in truth, every shore is temporary. Each horizon a fleeting arrangement in a cycle that has repeated for billions of years. To know this is to see the oceans in a new light. They are not simply vast reservoirs of water, but expressions of Earth's inner restlessness. The tides that rise and fall daily may seem the rhythm of the sea, yet beneath them lies another rhythm, slower and deeper, measured in ages rather than hours. It is the rhythm of continents parting and colliding, of ridges lifting and trenches yawning open, a planetary heartbeat that never stops. What we call the ocean today is in truth the story of change, written across unimaginable spans of time. The next time you hear the waves rolling in, remember that beneath them lies a floor that is younger than the dinosaurs. A floor that has been created and destroyed countless times before. It is a reminder that even the oceans themselves are a part of Earth's endless journey, a journey of plates and basins, of spreading and subduction, always moving, always remaking the stage upon which life unfolds. The surface of the ocean is only the beginning of its story. Far below the waves lies a world so extreme, so alien that it might as well be another planet, These are the trenches and abyssal plains, places where the ocean floor plunges into darkness, where pressure crushes and light cannot reach, and where Earth hides some of its most dramatic landscapes. The deepest known point on our planet is the Challenger Deep, located in the Mariana Trench of the Western Pacific. It sinks to nearly 7 miles, deeper than Mount Everest is tall. If you were to drop the mountain into this watery chasm, its summit would still be smothered by more than a mile of water. The name Challenger comes from the HMS Challenger expedition of the 1870s, the first scientific voyage to attempt systematic measurements of the deep sea. Even then, scientists could hardly have imagined just how far the seafloor descends. The Mariana Trench itself stretches for more than 1,500 miles, a long scar where the Pacific Plate is being shoved beneath the smaller Mariana Plate. The trench is not a simple hole, but a vast geological structure, its walls steep and unstable, its floor hidden beneath immense weight. Nearby lies another abyss, the Puerto Rico Trench in the Atlantic, the deepest part of that ocean, plunging to more than 5 miles. Each ocean has its own deepest pocket, reminding us that the Earth's crust is forever bending, breaking, and folding under the force of plate tectonics. At these depths, pressure is the true master. For every 33 feet of descent, the weight of the water above increases by 1 atmosphere, equal to the air pressure we feel at sea level. By the time you reach the Challenger Deep, the pressure is more than 1,000 times greater than at the surface. It is the equivalent of balancing 50 jumbo jets on your shoulders. Ordinary submarines would crumple like tin cans. Only a handful of specially designed vessels have ever dared the journey, including Jacques Picard and Don Walsh in their bathyscaphe Trieste in 1960, filmmaker James Cameron in 2012, and more recently, Victor Vescovo in a series of modern dives. Fewer people have visited the deepest trenches than have stood on the surface of the moon. The environment is as hostile as it is mysterious. Sunlight cannot penetrate past a few hundred meters, so these depths are cloaked in eternal night. The water temperature hovers just above freezing, and food is scarce, yet life has found a way. The seafloor here is dotted with the remains of marine snow, a gentle rain of dead plankton, organic debris, and microscopic particles drifting down from above. Strange creatures feed on this meager supply, evolving extraordinary adaptations to endure the crushing pressure and darkness. Transparent amphipods, snailfish with gelatinous bodies, and bizarre worms are among the residents of this silent realm. Beyond the trenches lie the abyssal plains, vast stretches of deep ocean floor between 2 and 4 miles down. These plains cover more than half of Earth's surface, making them the most common landscape on the planet, though few will ever see them. They appear deceptively flat, but they are punctuated by seamounts, ridges, and the occasional volcano. Sediment falls slowly through the water, building up layers over millions of years, so that in some places, the abyssal mud holds a record of ancient climates and vanished ecosystems. Even in these inhospitable depths, nature has conjured wonders. Hydrothermal vents discovered in the 1970s are perhaps the most remarkable. Along mid-ocean ridges and trenches, seawater seeps into cracks in the crust, is superheated by magma, and then gushes back out in plumes of mineral-rich water. The result is a scene that looks more like science fiction than Earth. Black chimneys belching smoky jets, white towers encrusted with strange crystals, and entire ecosystems clustered around the heat. What makes these vents extraordinary is that they are powered not by sunlight, but by chemistry. Bacteria harness energy from the minerals and gases spewing from the earth, forming the base of a food chain that supports giant tube worms, blind crabs, and fish with otherworldly appearances. In the pitch-dark ocean, far from the reach of the sun, life flourishes in a way that no one predicted. These discoveries have even inspired speculation about life elsewhere in the universe. If organisms can thrive here, perhaps they might also exist in the hidden oceans of moons like Europa or Enceladus. Yet despite all of this richness, our knowledge of the deep remains remarkably thin. The moon, more than 240,000 miles away, has been mapped and photographed in exquisite detail. The ocean floor, by contrast, is largely unmapped, its contours known only in rough outline. Satellites can detect tiny variations in sea surface height that hint at the mountains and trenches below, but vast areas remain a mystery. To explore the deepest places requires ships, submersibles, and technologies that are expensive, fragile, and daring. As a result, less than a quarter of the global seafloor has been surveyed in detail. The scale of the unknown is humbling. We know more about the craters of Mars than the trenches beneath the Pacific. We have walked on the moon, but we have only dipped our toes into the deepest abyss of our own planet. Every expedition reveals something unexpected, a new species, an unusual mineral deposit, or a glimpse of the strange interactions between Earth's interior and the water above. Reflecting on the trenches and abyssal plains, one is struck by the paradox of familiarity and mystery. The oceans define our planet, visible from every shore and even from space, yet their most profound depths remain hidden. It is as if Earth has kept its greatest secrets tucked away, waiting patiently for us to look. When you gaze at the sea from the surface, calm and glittering under the sun, it is worth remembering that beneath lies a world of extremes. Valleys deeper than mountains are tall, plains vaster than continents, vents that breathe heat into the dark, and creatures shaped by pressures we can hardly comprehend. These are the deepest places where silence reigns and time seems to move differently. They are reminders that our planet is still full of mysteries, waiting in the darkness, as unexplored as distant worlds above the sky. Long before forests rose on land or birds filled the skies, the oceans were already alive. They were not just the backdrop for life's story. They were the stage upon which it began. In those early seas, chemistry turned into biology, and the first cells found a way to endure, divide, and eventually transform the planet itself. The earliest evidence of life comes from around 3.8 billion years ago, a time when Earth was still young and violent. The sun was dimmer, the air was thick with volcanic gases, and yet in shallow coastal waters, tiny microbial communities were flourishing. These were simple organisms by today's standards. No plants, no animals, not even the complexity of a fungus. But their achievement was monumental. They had learned how to take the raw materials of their environment and use them to sustain themselves. One of the most fascinating relics of this ancient world can still be found today. Stromatolites. These layered structures, built up by colonies of cyanobacteria, represent some of the earliest ecosystems on Earth. Picture thin mats of microbes growing in warm, shallow seas, trapping sediments, and slowly building stony mounds over time. Each layer marks a cycle of life and growth, an ancient diary written in stone by creatures too small to see. In places like Shark Bay in Australia, modern stromatolites still rise above the tide, offering a living glimpse into the earliest chapters of life. The cyanobacteria that built stromatolites also accomplished something that would forever change the planet: photosynthesis. By using sunlight to split water and fix carbon, they released oxygen as a byproduct. At first, this oxygen reacted with iron dissolved in the oceans, creating the banded iron deposits of rust-colored rock that are still mined today. But as the process continued, oxygen began to accumulate in the atmosphere. This event, often called the Great Oxidation, transformed Earth's environment. For some microbes, oxygen was poison. For others, it was an opportunity. In the long run, it laid the foundation for the energy-hungry complexity of multicellular life. For billions of years, the seas remained the sole domain of life. Microbes adapted to every niche: shallow lagoons, hydrothermal vents, and drifting mats on the open ocean. Slowly, over eons, some began to cluster into larger, more complex forms. The fossil record tells us that sponges appeared more than 600 million years ago, filtering seawater through their simple bodies. Soon after came jellyfish, corals, and the first hints of creatures with symmetry and movement. The oceans were stirring with new possibilities. Then, around 540 million years ago, the stage erupted in one of the most dramatic events in natural history: the Cambrian explosion. Within a relatively short span of geological time, perhaps only a few tens of millions of years, life diversified with astonishing speed. The seas filled with animals sporting shells, spines, eyes, and limbs. Predation appeared for the first time, driving an evolutionary arms race. Creatures dug into the seabed, swam through the water, or clung to reefs. Fossil sites like the Burgess Shale in Canada preserve this burst of creativity in remarkable detail, showing us bizarre and wonderful organisms that look both alien and strangely familiar. Trilobites, with their segmented bodies and faceted eyes, scuttled across the seafloor in countless numbers. In fact, if you think the ocean is busy today, you should have seen it 500 million years ago. Trilobites everywhere, as common then as crabs are now. Alongside them swam early arthropods, worms, and creatures that defy neat classification. Some had grasping claws like a science fiction monster. Others resembled flattened pancakes with fins. For the first time, the ocean hosted real ecosystems with predators: prey, scavengers, and builders, all interacting in intricate webs. This explosion of diversity was fueled in part by oxygen. With more of it available in the atmosphere and dissolved in seawater, animals could grow larger and support more complex body plans. Hard shells also began to appear, providing protection and creating the first true fossils. The oceans, once dominated by soft-bodied forms, now rang with the crunch and scrape of shells and teeth. The Cambrian seas were also a time of experimentation. Many lineages tried unusual designs, and not all were successful. Some vanished almost as quickly as they appeared, leaving only curious fossils behind. Others gave rise to groups that still dominate the seas today, ancestors of modern arthropods, mollusks, and chordates. Hidden among these early swimmers were the first vertebrates, small fish-like creatures with simple backbones that would one day lead to the rise of fish, amphibians, reptiles, birds, and mammals. Through all of this, the ocean served as both cradle and canvas. They provided the space for life to experiment, the nutrients to sustain it, and the currents to spread it. Shallow seas along continental shelves were particularly rich, acting as nurseries where diversity flourished. Deeper waters harbored stranger forms, but even there, life found ways to thrive. The legacy of those early oceans is still with us. Every breath of oxygen we take is a gift from ancient cyanobacteria. The genetic blueprints of the Cambrian explosion still echo in our own bodies, in the segmented muscles, paired limbs, and nervous systems that trace their origins to the sea. Even our blood carries a memory of the ocean, its salt balance reflecting the chemistry of primordial seawater. It is humbling to realize that when you look at the ocean today, you're gazing at the same setting, where life began its long adventure. The tides that rise and fall, the waves that break against the shore, these rhythms have been in place since the first microbes learned to harvest sunlight. The sea is not just a body of water. It is the ancient home of every creature that has ever lived, ourselves included. So when you picture those earliest times, do not imagine empty, barren seas. Instead, imagine bustling microbial mats, stromatolite reefs shimmering under a young sun, and Cambrian waters swarming with trilobites, worms, and strange predators with clawed appendages. The oceans were alive with possibility, a grand experiment that continues even now. From those first simple cells to the riot of creatures that filled the Cambrian seas, the ocean has always been life's greatest theater. It remains so today, carrying forward a story that began billions of years ago in shallow waters, where sunlight, chemistry, and patience conspired to create something entirely new, the living world. The ocean does not sit still. Even on the calmest of days, when the surface is like glass and the air is hushed, the water is always moving. Twice each day, the sea draws back from the shore and then returns, breathing in and out with a rhythm older than humanity itself. These are the tides, the gentle yet powerful heartbeat of the planet, dictated by forces that reach far beyond the Earth. At the core of this phenomenon lies gravity, that universal pull that keeps our feet on the ground and the planets in their orbits. The moon, small compared to Earth, but close enough to exert influence, tugs at the oceans as it circles overhead. Water, being fluid and free to move, responds to this pull, bulging outward on the side of Earth nearest the moon. Curiously, another bulge forms on the opposite side as well, created not by a direct tug, but by the inertia of water resisting Earth's own movement. The result is 2 high tides and 2 low tides in most places each day, a repeating cycle tied to the steady journey of the moon. The sun, far more massive but also much more distant, adds its own gravitational voice to this dance. When the sun, moon, and Earth align during a new or full moon, their pulls combine, producing especially high and low tides known as spring tides. Despite the name, they have nothing to do with the season of spring. Instead, the word comes from the idea of water springing forth. During these times, coastlines experience some of their most dramatic tidal shifts. By contrast, when the sun and moon form a right angle relative to Earth, their pulls partially cancel out, creating gentler, neap tides. These ebb and flow with less drama, but they are just as much a part of the ocean's steady breathing. For as long as humans have lived along coasts, tides have shaped daily existence. Ancient communities learned quickly that timing the tides could mean the difference between a safe journey and disaster. Fishermen knew when to set out and when to return, while sailors relied on tidal currents to help carry them through narrow straits. In many parts of the world, tide tables became as important as calendars. Even today, ports and shipping routes depend on precise knowledge of tidal patterns. Modern science can predict them years in advance, but the principle is the same. To live by the sea is to live by its rhythm. Nature, too, has woven itself around the tides. On rocky shores, entire ecosystems rise and fall with the water. Barnacles and mussels cling to stones, closing tightly when the tide retreats and opening when waves return with food. Crabs scuttle between pools, waiting for the right moment to forage. Seaweeds anchor themselves where they will be submerged, long enough to thrive, but exposed enough to capture sunlight. These zones are so finely tuned to tidal movement that a difference of only a few meters can mean the difference between survival and struggle. Some species have evolved to follow the tides with uncanny precision. The grunion fish of California, for example, comes ashore only during the higher spring tides, laying its eggs in the damp sand. 2 weeks later, another spring tide washes in, releasing the hatched larvae into the sea. Other creatures use tides as signals for migration or spawning, synchronizing their life cycles with the moon's pull. In this way, the tides are not just movements of water, but movements of time, guiding the rhythms of countless organisms. Beyond biology, the tides leave their mark on landscapes. Estuaries, where rivers meet the sea, are shaped daily by the ebb and flow, creating mud flats and salt marshes rich with life. Tidal currents carve channels, deposit sediments, and influence where human settlements can safely stand. In some places, tidal ranges are astonishing. The Bay of Fundy in Canada, for instance, sees water levels rise and fall by as much as 52 feet, the highest tidal difference in the world. Imagine a ship floating serenely at one moment and then resting on bare ground only a few hours later. It is a reminder of the sheer power behind this otherwise gentle-seeming cycle. Of course, tides also inspire wonder and reflection. For poets and philosophers, the moonlit tides have long symbolized change, patience, and inevitability. They move with a rhythm so steady that generations have trusted them, yet they are never exactly the same. Each tide carries a subtle difference, a tiny reminder that nature never truly repeats itself. To watch the ocean retreat, leaving behind glistening sand and pools teeming with life, is to glimpse the passage of time made visible. To see it return, swelling higher with every wave, is to be reminded that nature always keeps its appointments. Science has taken this understanding further. Tidal forces do more than move water. They also influence Earth's rotation. The friction of water sliding against the seafloor gradually slows the spin of the planet, lengthening days by fractions of a second over millions of years. Long ago, when life was just beginning, days were only about 18 hours long. Thanks to the pull of the moon and the ceaseless drag of the tides, Earth's rotation has stretched, giving us the 24-hour cycle we now take for granted. In some places, humans have even learned to harness tidal power directly. Modern turbines placed in fast-flowing tidal channels capture energy as water surges past, offering a renewable source of electricity. Unlike the wind or the sun, the tides are entirely predictable. They may be ancient, but they can still power the technologies of the present. Yet even with all their utility, tides retain their air of mystery. They connect us to forces far beyond Earth, linking the movement of water at our feet to the distant gravity of the sun and moon. Every gentle lap at the shore is a reminder that we live in a cosmos of connections, where even the pull of a satellite hundreds of thousands of kilometers away can stir the vastest oceans. To sit by the sea and watch the water rise and fall is to witness one of the most enduring rhythms of the natural world. Long before humans walked the earth, tides were sweeping across newborn shores. Long after we are gone, they will continue steady and sure, an ancient breath that never ceases. In their constancy there is comfort. The tides remind us that while so much on land changes swiftly, the ocean keeps its time with patience, guided by celestial hands. Like a heartbeat that pulses without pause, the tides continue to shape coasts, nurture life, and guide our journeys. They are both ordinary and extraordinary, familiar yet cosmic. A reminder that the simple act of water rising and falling is one of the most profound connections between our world and the wider universe. The ocean may appear vast and still, but beneath the surface it is always moving, flowing with powerful rivers of water that shape weather, sculpt coastlines, and tie distant corners of the globe together. These movements are the currents, the hidden highways of the sea. Unlike tides, which are guided by the steady pull of the moon and the sun, currents are driven by wind, temperature, salt, and the turning of the earth itself. Together they weave a complex circulation system that keeps our planet habitable. One of the most famous of these watery giants is the Gulf Stream. Flowing northward from the Gulf of Mexico, it snakes along the eastern coast of the United States before veering across the Atlantic toward Europe. Warm, swift, and immense, the Gulf Stream moves more water than all the world's rivers combined. Its influence is profound. Without it, much of northern Europe would be locked in icy winters, far harsher than what people know today. Instead, cities like London and Paris enjoy relatively mild climates, thanks to tropical warmth carried thousands of kilometers by this current. Across the Pacific, another great current surges, the Kuroshio. Its name means black stream in Japanese, a nod to its deep, dark waters. Like the Gulf Stream, it carries warm, tropical water northward, sweeping along the coasts of Taiwan and Japan. It is fast, narrow, and powerful, often compared to a marine jet stream. Sailors through history have both feared and relied upon it, as it could either speed a journey or sweep ships wildly off course. Even today, it remains vital for fisheries and weather patterns across East Asia. Then there is the mightiest of them all, the Antarctic circumpolar current. Unlike other currents that are hemmed in by continents, this one encircles the globe unbroken, racing eastward around Antarctica. It is the only current to travel completely around the Earth, linking the Atlantic, Pacific, and Indian Oceans in a single continuous flow. It acts as a thermal barrier, keeping the icy waters of the Antarctic largely isolated from warmer northern seas. This circulation not only regulates global climate, but also helps control the exchange of carbon dioxide between the ocean and the atmosphere. In a sense, it is one of Earth's most important regulators, a silent guardian of climate stability. Currents do not exist in isolation. They're part of a planetary circulation system, sometimes called the global conveyor belt. This system is driven by differences in temperature and salinity, what scientists call thermohaline circulation in high latitudes. Cold water grows dense as it cools and becomes saltier through the formation of sea ice. This heavy water sinks and begins a slow journey through the depths, creeping across the ocean floor until it rises again thousands of kilometers away. The process takes centuries, yet it connects every ocean basin, blending heat and nutrients, knitting the seas into one vast system. This conveyor belt helps regulate climate across the world. When warm surface currents release heat into the atmosphere, they soften winters in far-flung lands. Cold, deep currents carry oxygen and nutrients that feed entire ecosystems. A disruption in this circulation could have dramatic consequences. Scientists believe that shifts in ocean currents may have triggered abrupt climate changes in the past, plunging regions into sudden cold spells or altering rainfall patterns across continents. It is a reminder that the oceans are not passive backdrops, but active engines of the climate we depend upon. For humanity, the movements of the sea have always mattered. Long before satellites and weather forecasts, sailors relied on knowledge of currents and winds to guide their voyages. The trade winds and their accompanying currents carried early explorers across vast distances, linking continents long before steamships or airplanes existed. Polynesian navigators read the subtle signs of waves and swells, steering canoes across the open Pacific. European sailors charted the great gyres, circular systems of currents to speed their journeys across the Atlantic and Indian Oceans. Entire empires were built upon the reliable flows of wind and water. The connection between currents and commerce cannot be overstated. The triangular trade routes of the early modern period, however grim their cargo, were made possible by the predictability of these flows. To move sugar, cotton, and enslaved people across oceans required not just ships, but an intimate knowledge of how water and air carried them. Even today, shipping lanes often align with major currents, saving fuel by letting nature do part of the work. Beyond navigation and trade, currents have shaped culture and history in quieter ways. Fishing communities depend on nutrient-rich upwellings where currents bring food from the deep to the surface. Regions like Peru's coast thrive on the Humboldt Current, which sustains some of the richest fisheries in the world. At times, changes in these flows can cause famine or abundance, reminding people of their deep dependence on the invisible rivers beneath the waves. Currents also remind us of just how interconnected the world's oceans truly are. A piece of driftwood cast into the sea off Africa may wash up years later on a distant Pacific island, carried along by gyres and eddies. Bottles, buoys, and sadly even plastic circle the globe in similar ways. Proof that the ocean circulation links all shores. Currents bind the seas into one vast body of water, erasing the idea of separate oceans and replacing it with a single restless entity. The physics behind these flows is complex, but the experience of them is deeply human. To stand on the shore and feel a warm current lapping your feet is to touch water that began its journey half a world away. To sail with a steady following wind is to ride a pathway carved not by roads but by nature's own hand. Despite centuries of study, currents continue to surprise. Satellites reveal swirling eddies hundreds of kilometers wide that spin off the main flows, transporting heat and life into unexpected regions. Climate scientists watch closely for signs of change, knowing that even small shifts can ripple outward into weather, agriculture, and society. There is a quiet poetry in the thought that invisible rivers run through the ocean, carrying warmth, life, and memory across the planet. They are ancient, yet they move with every gust of wind and every change of season. They are unseen, yet they shape the lives of billions. The ocean's currents are not simply flows of water. They are the circulatory system of Earth, pulsing with energy and connection. They remind us that the sea is alive with motion, always breathing, always moving, always carrying the past into the present, and the present into the future. The coastline is the meeting place of two worlds. Here, the solidity of land meets the restlessness of the sea, and neither side ever truly wins. The line may look fixed on a map, but in reality it is in constant motion, sculpted daily by tides, storms, and the slow persistence of waves. To walk along a beach or stand atop a cliff is to stand on a frontier that is forever changing, a boundary that resists permanence. Beaches are perhaps the most familiar face of the coastline. They seem simple at first glance, stretches of sand or pebbles where waves break and retreat. Yet they are dynamic systems endlessly shifting with the winds and seasons. A beach is not a stable structure, but a collection of grains in motion, pushed up by waves, pulled down by undertows carried along the shore by longshore drift. One storm can strip away sand, leaving rocks exposed, while another can deposit new layers overnight. To think of a beach as permanent is a mistake. It is a landscape drawn and redrawn with every tide. Cliffs tell a different story, one of resistance and collapse. Towering faces of rock stand against the sea. Yet even the hardest stone eventually yields to the persistence of waves. The white chalk cliffs of Dover, the basalt walls of Ireland's Giant's Causeway, and the rugged granite of Big Sur in California all testify to the ceaseless work of erosion. Waves pound at their bases, carving caves that grow into arches, arches that crumble into stacks, and stacks that eventually fall into the sea. It is a slow drama played out over centuries, but also one that can shift in a single, violent storm. Between the beaches and cliffs lie estuaries, those wide, sheltered mouths where rivers meet the ocean. Estuaries are nurseries of life, brimming with nutrients, carried downstream and mixed by the tides. Salt marshes, mudflats, and mangroves flourish here, creating some of the richest habitats on Earth. Birds flock in their thousands to feed. Fish spawn in the brackish waters. And communities of people have long relied on estuaries as safe harbors and fertile grounds. The Thames in London, the Hudson in New York, the Ganges in India, all flow into great estuaries that have nurtured trade, settlement, and culture. Deltas tell yet another tale. Formed when rivers deposit their sediment faster than the sea can carry it away, they create sprawling networks of channels and islands. The Nile Delta, shaped by thousands of years of flood and silt, was the cradle of Egyptian civilization. The Mississippi Delta, with its tangled bayous, has given rise to unique cultures and ecosystems. The Ganges-Brahmaputra Delta, the largest in the world, supports hundreds of millions of people. Deltas are both gifts and challenges, fertile lands for farming, yet fragile and vulnerable to rising seas. All of these coastal forms, beaches, cliffs, estuaries, and deltas, exist in delicate balance with the forces that shape them. Waves arrive endlessly, their energy eroding one place and building another. Tides surge and retreat, flushing estuaries and sculpting salt marshes. Currents carry sand, shifting shorelines over decades and centuries. Even human efforts to pin the coast in place with seawalls or groins often prove temporary as the sea finds ways to move regardless of our designs. The coast has always held special meaning for humanity. It is at once a boundary and a gateway. For early peoples, the shore was a place of abundance where fish could be caught, shellfish gathered, and trade with distant lands imagined. Settlements clustered along coastlines, not just for resources, but for the opportunities of connection. Ports became the hearts of empires, places where ships set out and returned with cargoes of goods, stories, and ideas. Culturally, the coast is rich with symbolism. It has been a place of departure and return, of longing and discovery. Ancient myths often begin with heroes gazing at the horizon, wondering what lies beyond. Poets have compared waves to the passage of time, each one a reminder of life cycles. To many, the sea has represented the unknown and the coast the threshold to it. Even today, vacations by the sea remain a universal draw, perhaps because standing at the edge of land awakens something deep within us. A sense of vastness, of perspective, of being small in the face of something immense. Yet the coast is not just romantic, it is also perilous. Storm surges, tsunamis, and rising seas remind us that to live at the edge of the ocean is to accept risk. Entire towns have been swallowed by encroaching waters, while others cling precariously to eroding cliffs. The very qualities that make coastlines so vibrant, their constant reshaping, their restless energy, also make them fragile. Despite this, people return again and again to the shore. Perhaps it is the lure of abundance, the promise of trade, or simply the timeless rhythm of waves. The coast is where cultures meet, where ships arrive with unfamiliar goods, where languages mix, and where civilizations are transformed by contact. The Silk Road may have linked Asia to Europe by land, but the maritime routes that crossed oceans did just as much to shape history. Ports like Alexandria, Venice, and Guangzhou were not just economic centers, but cultural crossroads where ideas, technologies, and stories flowed as freely as spices and silk. Even today, nearly half of humanity lives within 100 kilometers of the sea. Coasts remain magnets for settlement, for industry, for leisure. Cities like Tokyo, Mumbai, New York, and Rio de Janeiro all thrive at the edge of land and water. The coast continues to be a stage upon which history unfolds as vital now as it was in ancient times. To walk along a shoreline is to see both the work of nature and the imprint of humanity. You may notice the delicate ripples etched by the last tide, the shells scattered like tiny sculptures, the footprints that vanish as the waves return. You may stand before cliffs that tell of millions of years of geological history, or wander through a harbor that has seen centuries of arrivals and departures. Every coast carries stories of nature, of people, of change. In the end, the coastline is more than a line on a map. It is a living boundary, always shifting, always testing the balance between land and sea. It is a place where Earth reveals its restlessness and where humanity has found both opportunity and challenge. To gaze upon it is to see the meeting of two forces, each powerful in its own way, shaping not only landscapes, but the course of civilizations. Among the ocean's many wonders, few are as dazzling or as delicate as coral reefs. They are sometimes called the rainforest of the sea, and for good reason. Bursting with color, teeming with life, and supporting ecosystems of staggering complexity. Reefs are among the most biodiverse habitats on Earth. Yet for all their beauty, they're also astonishingly fragile, living right on the edge of what is possible in nature. At their core, reefs are built by some of the smallest and simplest of creatures, corals. Despite their rocky appearance, corals are not plants or stones, but colonies of tiny animals known as polyps. Each polyp is little more than a soft-bodied cylinder crowned with tentacles. Yet together they work wonders. They secrete calcium carbonate, building hard skeletons that form the foundation of the reef. Over time, as generations live and die, their skeletons pile up, creating immense structures that can stretch for hundreds of kilometers. It is slow work. Many reefs grow only a few centimeters per year. But given centuries and millennia, the result is one of the most spectacular landscapes on the planet. Corals could not accomplish this feat alone. They owe much of their success to a microscopic partner, symbiotic algae called zooxanthellae. These algae live inside the coral's tissues, photosynthesizing in the sunlight and sharing the nutrients they produce with their hosts. In exchange, the algae gain protection and access to the coral's waste products, which serve as fertilizer. This partnership is so efficient that it allows reefs to flourish even in waters that are otherwise nutrient poor. The corals, fed by sunlight and algae, build vast limestone fortresses in places where most other life would struggle. The result is a habitat that supports a bewildering variety of organisms. Fish dart among the corals in every imaginable color and shape, from tiny damselfish to large groupers and reef sharks. Crustaceans, mollusks, sponges, and countless invertebrates make their homes in the crevices. Sea turtles glide by. Parrotfish crunch at the coral, and octopuses hide in the nooks, changing color to blend into the background. A single reef can host thousands of species, many of them found nowhere else in the world. The interactions are intricate. Some fish clean parasites off others. Some form hunting alliances across species, and some rely entirely on the reef for every stage of their life cycle. The Great Barrier Reef is the most famous example, sprawling along Australia's northeastern coast for more than 2,400 miles. It is so vast it can be seen from space, a living structure larger than many countries. But it is not alone. Reefs encircle islands throughout the Pacific, from the atolls of the Maldives to the coral gardens of Fiji. The Red Sea harbors reefs of striking diversity, while the Caribbean hosts a chain of reefs that sustain both wildlife and local communities. Each reef is unique, shaped by its history, its waters, and the species that inhabit it. These ecosystems are not just breathtakingly beautiful, they're also invaluable. They provide food for hundreds of millions of people, support fisheries worth billions of dollars, and protect coastlines by absorbing the force of waves. They are sources of new medicines as scientists study the compounds produced by reef organisms for potential use in treating diseases. And beyond the practical, they offer something less tangible, but no less important: wonder. To dive into a reef is to enter a kaleidoscope of life, a place so vibrant that it feels almost unreal. Yet reefs live on the edge of survival. They require clear, warm, shallow waters with just the right temperature range. A few degrees too hot and corals expel their algae partners, turning ghostly white in a process known as bleaching. Prolonged bleaching can kill entire colonies. Rising ocean temperatures caused by climate change have already led to mass bleaching events across the globe, including devastating losses in the Great Barrier Reef. Pollution, overfishing, and sedimentation add further stress, while ocean acidification, caused by increased carbon dioxide dissolving into seawater, weakens the ability of corals to build their skeletons. Despite these challenges, reefs have shown resilience in the past. They have survived ice ages, sea level changes, and natural disasters. Given time and protection, many can recover, though often in new forms. Conservation efforts, from marine protected areas to reef restoration projects, aim to give them that chance. Scientists are experimenting with coral nurseries, selective breeding of heat-resistant corals, and even artificial structures to encourage regrowth. Communities are learning that protecting reefs is not only an environmental duty, but an economic necessity. The fragility of coral reefs is part of what makes them so precious. They remind us that beauty in nature often comes with vulnerability, that the most intricate systems can also be the most easily undone. To stand on a shore and know that just beneath the waves lies a city of coral, alive with the movement of fish and the flicker of sunlight, is to recognize how extraordinary our planet truly is. Coral reefs also invite reflection on time. The polyps that build them are tiny, their lives measured in days. Yet together they construct monuments that endure for millennia. They're an example of how cooperation and patience in nature can create something far greater than the sum of its parts. The reef is both ancient and immediate, both vast and composed of the smallest of creatures. There is a gentle humor, too, in the contrast between the grandeur of reefs and the modesty of their builders. The Great Barrier. Reef may be larger than Italy, yet it is the handiwork of animals no bigger than a grain of rice. These unassuming architects have, without intention, created some of the most remarkable structures on Earth. To reflect on coral reefs is to be reminded of both wonder and responsibility. They're jewels of the ocean, dazzling in their complexity, yet fragile enough to vanish within a generation if neglected. Protecting them is not only about preserving beauty, but about safeguarding the foundation of ecosystems, cultures, and livelihoods. When you think of coral reefs, imagine not only the vibrant colors and darting fish, but also the quiet persistence of billions of tiny creatures working in harmony. Picture the balance of life they sustain, the protection they offer to coasts, and the inspiration they give to anyone fortunate enough to witness them. They're in every sense rainforests beneath the waves, intricate, vital, and irreplaceable. The open ocean is the largest habitat on Earth, stretching across more than 70% of the planet's surface. Yet it is often described as a desert. At first, this may sound contradictory. How can a realm of endless water be compared to a barren wasteland? The answer lies in its scale and its sparseness. Food is patchy, landmarks are non-existent, and distances are almost unimaginable. To journey across the open sea is to confront both the immensity of the world and the smallness of oneself. Scientists divide this vast space into zones, each with its own character. The epipelagic zone, often called the sunlight zone, extends down about 650 feet. Here, sunlight penetrates the water, fueling photosynthesis and driving the growth of phytoplankton. These microscopic drifters are the foundation of oceanic food webs, tiny plants that feed tiny animals, which in turn sustain fish, whales, and seabirds. The epipelagic may look empty, but it is bustling with life. From shoals of sardines shimmering like liquid silver to dolphins slicing through waves. Beneath lies the mesopelagic, the twilight zone stretching from 650 to about 3,300 feet. Sunlight fades here to a dim gloom too weak for photosynthesis, but not yet fully dark. It is a world of silhouettes and shadows inhabited by creatures adapted to ambiguity. Lanternfish, which glow with bioluminescent organs, are among the most numerous vertebrates on the planet. Yet you will rarely see them at the surface. Squid dart through the half-light while strange gelatinous forms drift like living lanterns. Many of the inhabitants of the Twilight Zone participate in the largest migration on Earth, a nightly ascent toward the surface to feed, followed by a retreat into darkness at dawn. Billions upon billions of animals make this journey each day, a hidden movement that dwarfs even the migrations of wildebeest or monarch butterflies. Descending deeper still brings you to the bathypelagic zone, often called the midnight zone. Sunlight never reaches here. Pressures mount, temperatures plummet, and darkness is absolute. Life continues nonetheless, though it takes on forms that seem plucked from a dream. Anglerfish dangle glowing lures to attract prey. Gulper eels open mouths as wide as their bodies, and translucent creatures drift like apparitions. Food is scarce, delivered in the form of marine snow, the slow drizzle of organic matter falling from above. In this endless night, survival depends on patience and ingenuity. Though these zones define depth, they also highlight just how little humans truly know about the open ocean. Vast stretches remain unobserved, their inhabitants glimpsed only when dragged up in nets or captured by the occasional deep-sea camera. It is a reminder that the Great Blue Desert is not only enormous, but mysterious, a frontier still largely unexplored despite centuries of maritime history. Plankton, both plant-like phytoplankton and animal-like zooplankton, are the unassuming heroes of the open ocean. Invisible to the casual eye, they form the base of food chains and generate much of the oxygen in our atmosphere. A single breath you take thanks to the photosynthetic work of plankton, drifting far out at sea. Tiny as they are, they sustain whales, fish, and indirectly all who rely on the ocean for food. They remind us that productivity can come in the smallest of packages, even in a realm often perceived as empty. For larger animals, the open ocean is a place of astonishing migrations. Leatherback turtles cross entire ocean basins following jellyfish swarms. Humpback whales sing as they journey from polar feeding grounds to tropical breeding lagoons. Albatrosses, with wingspans stretching over 10 feet, glide for thousands of kilometers without rest, barely touching land from year to year. These creatures make the desert bloom with movement, tracing invisible highways that humans are only beginning to map. Yet for all its life, the open ocean can feel overwhelmingly empty. Imagine sailing across it in the days before engines and GPS, when weeks passed without sight of land, when the horizon was a perfect circle of sky and water. For many, this emptiness was terrifying, a reminder of isolation and vulnerability. Even today, passengers on ships or planes crossing the Pacific or Atlantic sometimes describe the eerie sensation of knowing that for hours there is nothing but water in every direction. The psychological effect of such vastness is profound. It humbles, unsettles, and inspires in equal measure. The comparison to a desert is apt not just because of the sparseness of resources, but also because of its capacity to overwhelm the senses. In deserts of sand, the horizon stretches endlessly, offering little guidance. In the open ocean, it is much the same. Navigation once depended on stars, winds, and currents, demanding extraordinary skill from early mariners. To be lost at sea was to be lost in the most literal sense, surrounded by water yet without sustenance. Despite these challenges, humans have always been drawn to cross the great blue expanses. Trade, exploration, migration, and curiosity have all pushed us into the open sea. The Polynesians, with their double-hulled canoes, crossed thousands of kilometers, guided by swells, bird flights, and the faint glow of distant islands. European explorers later set out into the Atlantic, uncertain of what they would find. Today, cargo ships and aircraft trace the same routes, though with far more certainty and comfort. In contemplating the open ocean, one cannot escape a sense of paradox. It is both full of life and eerily barren, both dynamic and monotonous. Its creatures include some of the smallest forms of life and some of the largest, from plankton barely visible under a microscope to blue whales longer than a city bus. It connects every shore, yet it can isolate those who venture into it. It is the desert of water, a realm that nourishes while also intimidating with its sheer scale. And still it is beautiful. The open ocean has a serenity all its own. The endless play of light on waves, the ever-changing shades of blue, the quiet roll of swells that seem timeless. It is not scenery you can measure by landmarks, but by moods, calm, stormy, playful, or brooding. To gaze upon it is to feel both peace and awe, to sense the pulse of a planet covered mostly by sea. Ultimately, the open ocean reminds us of the immensity of the world we inhabit. It is the great stage upon which migrations, cycles, and unseen processes unfold. It sustains life, regulates climate, and challenges human imagination. Though it may be called a desert, it is a desert brimming with hidden richness, a place that humbles and sustains in equal measure. When you look out over its endless horizon, you're staring not at emptiness, but at one of Earth's grandest mysteries, a wilderness of water stretching farther than the mind can easily comprehend. At the very edges of the Earth lie oceans unlike any others, wrapped in ice and shrouded in extremes. These are the polar seas, the Arctic Ocean in the north and the Southern Ocean that encircles Antarctica in the south. Both are places of stark beauty, bitter cold, and remarkable resilience, where life has adapted to conditions that would seem unlivable to most. Though they may feel distant and remote, they play a crucial role in shaping the climate of the entire planet. The Arctic Ocean is the smallest of Earth's major seas, almost entirely surrounded by continents. It is a semi-enclosed bowl of water capped by a shifting mosaic of sea ice. This ice grows each winter as the sun dips below the horizon for months on end, then shrinks again each summer under the endless daylight of the midnight sun. The annual freeze and thaw is one of the defining rhythms of the North, a seasonal heartbeat that influences weather, ecosystems, and human communities. At the other end of the world, the Southern Ocean circles Antarctica, free from the constraint of continents. Here, the Antarctic Circumpolar Current races unbroken around the globe, the only current that does so. This great conveyor keeps Antarctica isolated in a deep freeze, while at the same time linking the Atlantic, Pacific, and Indian Oceans. The waters here are stormy, restless, and vast, yet they are also among the most biologically productive on Earth, teeming with plankton that support entire food chains. Sea ice is central to both poles, and it is not just frozen seawater. When ice forms, it pushes salt out into the surrounding water, making it denser and causing it to sink. This process helps drive global ocean circulation, the great conveyor belt that carries heat around the world. The reflective surface of ice also bounces sunlight back into space, cooling the planet like a vast mirror. When ice melts, the darker ocean absorbs more heat, accelerating warming. Thus, the waxing and waning of polar ice is not only a local phenomenon, but a global regulator, a thermostat for the entire climate system. Despite the bitter conditions, life flourishes in both polar seas. Underneath the ice in the Arctic, algae cling to the underside, forming the base of a food web that includes krill, fish, seals, and polar bears. Narwhals glide through icy channels with their long tusks, while beluga whales chatter in social groups. Migratory birds travel thousands of kilometers to breed in the brief, frantic summer. In the Antarctic, the stars of the show are krill, tiny shrimp-like creatures that swarm in their billions. These swarms feed penguins, seals, whales, and seabirds, forming one of the richest ecosystems on the planet. Penguins in particular thrive in the Southern Ocean. Comical on land but superb swimmers at sea, they dive, twist, and rocket through the water with effortless grace. Humans, on the other hand, have a far harder time. The freezing winds, shifting ice, and long polar nights make survival a monumental challenge. Penguins thrive here. Humans not so much. Expeditions throughout history have proven just how unforgiving these places can be, with tales of endurance, disaster, and the occasional triumph etched into exploration lore. The polar seas have also shaped human imagination. For centuries, they were blank spots on maps, feared as icy wastelands, or dreamed of as gateways to hidden continents. Expeditions into these waters were acts of both science and sheer willpower, as ships creaked against crushing ice and crews endured months of darkness. Even today, venturing into the polar oceans demands respect. As modern vessels still contend with drifting icebergs, unpredictable storms, and biting cold, these oceans also hold immense scientific value. Ice cores drilled in Antarctica contain bubbles of air from hundreds of thousands of years ago, providing a direct record of past climates. Marine sediments tell stories of shifting currents, glacial cycles, and changes in productivity. Scientists working in the Arctic monitor the retreat of summer ice, a bellwether for global warming. Every year of observation adds urgency as both poles show signs of rapid change that will ripple far beyond their frozen shores. The importance of the polar seas to global climate cannot be overstated. By storing cold water and circulating heat, they help balance the temperature differences between equator and pole. They act as carbon sinks, absorbing vast amounts of carbon dioxide from the atmosphere. Yet, they are also sensitive indicators of change. The loss of Arctic sea ice, the thinning of Antarctic shelves, and the shifts in ecosystems all point to a planet in transition. For all their harshness, there is a strange peace in these places. The stillness of a frozen bay, the endless expanse of white merging with the horizon, the distant calls of seabirds echoing across the ice, all remind us that the Earth is capable of both ferocity and serenity. Standing at the edge of the polar sea, one feels the scale of the planet more acutely than almost anywhere else. These extremes, these margins of habitability, are not just curiosities at the far ends of the map. They're integral to the balance of the whole Earth system. The polar seas remind us that the planet is interconnected, that what happens in the ice influences the tropics, and the choices made in cities far from the poles can echo back in the form of melting glaciers and shifting ecosystems. To think of the polar oceans is to think of resilience and fragility side by side. They endure storms of unimaginable power. Yet a few degrees of warming can unravel their balance. They support some of the richest wildlife spectacles on Earth. Yet their survival depends on forces beyond their control. They are beautiful in their starkness, humbling in their scale, and vital in their role as guardians of Earth's climate. Though few will ever set foot on their shores or sail through their icy waters, the polar seas touch all of us. Every breath of air, every stable season, every shift in climate is influenced in part by the frozen north and south. To imagine the world without them is to imagine a planet unrecognizable from the one we call home. And so, even from afar, we remain bound to the Arctic and the Southern Ocean, two extremes that anchor the rhythms of the Earth. For as long as humans have gazed upon the horizon, the ocean has been more than water. It has been mystery, power, and story. Its vastness has inspired awe. Its tempests have sown fear. And its bounty has been both blessing and curse. No wonder, then, that across cultures and centuries, the sea has been woven into myth and imagination, personified in gods, feared as the dwelling place of monsters, and celebrated in songs and literature. In the ancient Mediterranean, the Greeks honored Poseidon, brother of Zeus and Hades, as lord of the seas. With his trident, he could calm waters or raise storms at will, a figure both generous and capricious. Sailors prayed to him for safe passage, offering sacrifices before venturing across open waters. The Romans adopted him as Neptune, keeping much of the same imagery. A reminder that the ocean was never simply a physical realm, but a divine one ruled by powers beyond human control. In the Hebrew Bible, the ocean is home to Leviathan, a monstrous sea serpent embodying chaos itself. To defeat Leviathan was to impose order upon the wild, to prove that the unpredictable depths could be subdued by divine will. Similar themes appear elsewhere. In Mesopotamian myth, the goddess Tiamat represented the primordial salt water, a dragon-like being who had to be overcome for the world to be created. The sea in these stories was not just a place, but a cosmic force, symbolizing both origin and danger. Far across the world, Polynesian traditions gave the ocean a different voice. For island peoples surrounded by water, the sea was not only a source of fear, but a highway of life. The hero Maui, common to many Polynesian cultures, is said to have fished up islands from the depths with his magical hook, giving shape to the archipelago scattered across the Pacific. Here, the sea is not simply an adversary, but a partner, a vast space that both challenges and provides. Norse mythology tells of Jormungandr, the world serpent so large that it encircles the earth and bites its own tail. Lurking in the deep, it was fated to rise during Ragnarok, thrashing and spewing poison to signal the end of the world. The image captures the ocean's dual nature, a circle enclosing all life, yet also a threat of destruction, always waiting beneath the surface. Beyond deities and monsters, the sea has also inspired countless human-made tales. Sailors spoke of krakens, colossal tentacled beasts capable of dragging entire ships into the depths. In the age of exploration, reports of mermaids spread across Europe, often born from glimpses of manatees or dugongs glimpsed at a distance. To a weary sailor, a pale figure rising from the waves might well have seemed otherworldly. These myths were more than entertainment. They were ways of giving shape to the unknown, explanations for the uncharted, and reflections of the deep unease that open water often provokes. But the ocean has always been more than a threat. It has been a giver of life, a source of food, and a path to discovery. Myths often reflect this duality. Poseidon could bring bounty as well as destruction. Maui, while mischievous, offered his people islands to live upon. Even Leviathan, while terrifying, confirmed the greatness of the divine power that could subdue it. To live near the sea was to understand that it could feed you one day and claim you the next. And so it was natural to weave both gratitude and fear into its stories. The sea also found its way into poetry and literature as a symbol of emotion and imagination. In Homer's epics, the ocean is a restless backdrop where Odysseus wanders for years, tossed by storms and divine whim. Shakespeare wrote of the deep and dark blue ocean as a place of both beauty and sorrow. In Coleridge's rhyme of the Ancient Mariner, the endless sea becomes a mirror of guilt and penance, a place where isolation and wonder intermingle. Writers across cultures have used the ocean as metaphor for freedom, for longing, for eternity, or for the unknown. Even today, the ocean persists in literature as a canvas for human feeling. It can stand for adventure, as in tales of exploration or pirate yarns. It can represent loss, as in stories of shipwrecks and disappearances. It can be a symbol of connection, binding continents and cultures together. Modern novels and films still return to the sea for its unmatched ability to evoke awe, danger, and discovery. Part of this imaginative hold comes from the simple fact that the ocean remains unknowable. Standing on the shore, one sees only the surface, the horizon that promises much but reveals little. What lies beneath is hidden, and what lies beyond is uncertain. For millennia, this gap in knowledge invited stories to fill it. Myths gave shape to what could not be seen, offering monsters where science had not yet ventured. Even now, with satellites and submarines, the deep retains its mystery, and imagination still clings to its shadows. The ocean is also a place of rhythm, its tides and waves inspiring music, chant, and verse. Coastal peoples have long sung songs that mimic the sea's cadences. From work chants, timed to rowing strokes, to lullabies that echo the hush of waves. The sea has entered language itself. We speak of waves of emotion, tides of history, currents of thought. The imagery reflects how deeply this watery realm runs in the human psyche. It is striking that across cultures separated by oceans themselves, similar themes arise. The sea is creation and destruction, home of gods and beasts, a place of passage and of peril. Whether envisioned as a nurturing mother or a devouring serpent, it occupies a central place in humanity's collective imagination. Perhaps this is inevitable, for no matter where people settled, the ocean was never far away. A horizon always present, a force always felt. In reflecting on these myths and stories, we glimpse how humans have always sought to make sense of the ocean's dual nature. It is both familiar and alien, both generous and cruel. It has filled nets with fish and swallowed fleets whole. It has connected cultures and isolated them. It has inspired gods, monsters, and metaphors, becoming one of the richest canvases for the human mind. The ocean's role in myth and imagination shows that it is not just water, but meaning. Every story told of Poseidon's wrath, every chant about Maui's hook, every poem about a storm-tossed ship reflects an attempt to capture the essence of the sea, vast, unpredictable, and deeply entwined with our fate. To this day, when we speak of mysteries, we call them unfathomable. The word itself comes from the sea, from the depths we cannot measure, from the sense that no matter how far we probe, the ocean will always hold something beyond reach. Thus, the ocean endures in our minds not only as geography, but as mythology, as symbol, and as story. It is the giver and the taker, the monster and the muse. The place where imagination has always found room to sail. For as long as people have gazed at the horizon, the ocean has tempted them to cross it. The vast expanse of water was never only a barrier, it was also a highway, a route that promised food, trade, and the possibility of new lands. Human history is in many ways a history of seafaring, of individuals and cultures who dared to trust fragile vessels against endless waves. From dugout canoes to mighty fleets, the ocean has been both the stage and the vehicle for some of humanity's greatest adventures. The Polynesians stand among the finest navigators the world has ever known. Thousands of years ago, long before science or compasses, they mastered the open Pacific, one of the largest and most unforgiving expanses of water on Earth. With double-hulled canoes built from wood and lashed with fiber, they sailed thousands of kilometers between islands scattered like grains of sand across the ocean. They read the stars as a map, the flight of birds as a guide, and the shape of swells beneath their canoes as a compass. Modern sailors marvel at their skill, for they accomplished what many would consider impossible. Deliberate voyages across vast stretches of water with nothing but the senses in the sky. Their journeys populated islands from Hawaii to New Zealand to Easter Island, shaping cultures that still carry the memory of those daring explorations. In the Mediterranean, another seafaring people were leaving their mark, the Phoenicians. From their city-states along the coast of present-day Lebanon, they launched ships that became the workhorses of ancient trade. They were known for their purple dye prized across the ancient world. But more than their goods, it was their seamanship that spread their influence. They charted routes across the Mediterranean, sailed beyond Gibraltar into the Atlantic, and established colonies that thrived for centuries. Carthage, their most famous colony, would one day rival Rome itself. The Phoenicians remind us that the ocean has always been more than water. It has been the medium through which ideas, languages, and cultures travel. Far to the north, the Vikings took to the sea with longships that were both beautiful and terrifying. Their vessels, sleek and shallow-drafted, could navigate both stormy seas and shallow rivers, giving them unparalleled reach. In the 9th and 10th centuries, they crossed from Scandinavia to Britain, France, and beyond, raiding, trading, and settling. Yet their ambitions did not stop there. They reached Iceland, Greenland, and even North America centuries before Columbus. The saga of Leif Erikson, who landed on the shores of Vinland, likely Newfoundland, is proof that the oceans carried people across the Atlantic long before the so-called Age of Discovery. The Vikings, often remembered as raiders, were also explorers of astonishing boldness. As the medieval world shifted into the Renaissance, the oceans became the stage for a new era of exploration. In the 15th century, Portuguese sailors, encouraged by Prince Henry the Navigator, edged southward along the coast of Africa. Using the caravel, a nimble and versatile ship, they learned the secrets of winds and currents that would open routes to India and beyond. Their voyages revealed the immense scale of the oceans and the opportunities that awaited those who could master them. Christopher Columbus, sailing under the Spanish crown in 1492, set out to reach Asia by heading west, and instead found himself in the Caribbean. His voyage marked a turning point, not because he was the first to cross the Atlantic, but because it opened an era of sustained contact between Europe and the Americas. The consequences were profound, altering the course of history, reshaping economies, and forever changing cultures on both sides of the ocean. A generation later, Ferdinand Magellan set out on a voyage that would become legendary. Though he himself did not survive the journey, his expedition completed the first circumnavigation of the globe. In doing so, it revealed the true vastness of the oceans. The Pacific, which Magellan named for its deceptively calm appearance, stretched far longer than his crew had imagined. Their survival was a testament to endurance and a stark reminder that the oceans could test even the most prepared. Not all exploration in this era came from Europe. In the early 15th century, the Chinese admiral Zheng He commanded massive fleets that sailed as far as Africa's east coast. His ships were marvels of engineering, some dwarfing the vessels of Europe, carrying treasure and displaying the might of the Ming dynasty. His voyages show that exploration was not merely about finding new lands, but also about projecting power, exchanging culture, and establishing presence across the seas. These stories highlight a truth. The oceans have always been highways of human history. They carried the Polynesians across the Pacific, the Phoenicians across the Mediterranean, the Vikings to new continents, and explorers into an interconnected world. Through the sea, spices traveled from the East Indies to Europe. Silk moved from China to Rome, and ideas leapt from one shore to another. Oceans were not empty gaps to be crossed, but vital arteries of civilization. The age of sail also transformed the world in unexpected ways. Currents and winds became as important as geography. Sailors learned to ride the trade winds across the Atlantic, then return on the westerlies, creating predictable loops that connected continents. These routes shaped colonization, commerce, and conflict for centuries. Ports grew into global cities, and navies became instruments of empire. The ocean became the stage upon which nations rose and fell. Yet beyond empire and wealth, exploration at sea carried a deeper human quality, curiosity. To launch into the unknown, to face storms and starvation, to watch the stars and trust that land lay beyond the horizon. These were acts of courage and imagination. Each voyage expanded not just maps, but minds, revealing that the world was larger, stranger, and more connected than anyone had believed. Even today, the romance of ocean exploration lingers. Space travel is often described as the new frontier, but it is worth remembering that for most of history, the ocean played that role. It was the mystery, the challenge, the endless expanse that demanded courage. Every time a ship slipped over the horizon, it was stepping into the unknown. That spirit of adventure, mingled with ambition, necessity, and sometimes greed, is part of what has carried humanity forward. The ocean has been humanity's greatest teacher of scale and humility. It has swallowed ships and given safe passage, enriched nations and humbled emperors. It has been the path of exploration and the canvas upon which history's greatest journeys have been painted. To reflect on the long story of seafaring is to recognize that the ocean is not just a backdrop to human history. It is one of its main characters, always present, always shaping the course of our collective story. For millennia, the ocean has been humanity's great marketplace. Long before aircraft and railways, the sea carried goods, ideas, and people farther and faster than land routes ever could. It became the Silk Road of water, a network of currents and harbors that stitched together civilizations separated by thousands of kilometers. To follow the story of trade across the oceans is to trace the threads of globalization, woven long before that word was ever invented. In antiquity, merchants plied the waters of the Indian Ocean, sailing monsoon winds between East Africa, Arabia, India, and Southeast Asia. These winds blew predictably out of the southwest during summer, out of the northeast during winter, creating a natural timetable for commerce. Spices, ivory, textiles, and precious stones moved along these watery highways. Chinese silk and porcelain made their way west, while gold, frankincense, and exotic woods traveled east. It was less a single route than a web of connections linking bustling ports from Zanzibar to Calicut to Malacca. The ocean was not an obstacle, but the essential bridge between worlds. This maritime Silk Road rivaled its overland cousin in significance. Caravans across deserts were slow and perilous, while ships could carry tons of cargo over great distances. The great empires of Rome, Persia, and later the Abbasid Caliphate thrived on the goods that arrived by sea. Archaeological finds of Roman coins in India or Chinese ceramics in East Africa testified to how far these networks stretched. The ocean turned distant strangers into trading partners, setting the stage for the first truly global interactions. As centuries passed, trade across the seas grew into the foundation of entire empires. The Portuguese, armed with caravels and navigational knowledge, carved out a network of forts and ports stretching from Lisbon to Goa to Malacca. The Spanish sailing west forged connections across the Atlantic and Pacific, bringing silver from the mines of the Americas to fuel Asian markets. Their Manila galleons crossed from Mexico to the Philippines, carrying silver one way and silk the other, an early conveyor belt of globalization. The Dutch followed, establishing the Dutch East India Company, one of the world's first multinational corporations. With their heavily armed ships and efficient organization, they dominated the spice trade for over a century. The British and French soon joined the competition, and naval power became inseparable from economic might. To control the sea was to control wealth. Ports were not just harbors. They were hubs of empires where taxes were collected, alliances forged, and fortunes made. Colonial networks depended on ocean trade, and with it came darker chapters of history. The Atlantic became the stage for the triangular trade where enslaved Africans were transported across to the Americas, their forced labor producing sugar, cotton, and tobacco that fed European markets. Ships became instruments not just of commerce, but of cruelty, their holds filled with human suffering. The wealth of many colonial powers was built on these grim voyages, a reminder that ocean trade has always carried both prosperity and exploitation. Yet beyond empire and exploitation, the sea continued to connect. Coffee from Yemen, tea from China, sugar from the Caribbean, and spices from Indonesia reshaped diets and cultures worldwide. The global palate expanded because oceans allowed goods to move on a scale unimaginable by land. A Londoner sipping tea with sugar in the 17th century was knowingly or not part of an international network of trade stretching across half the globe. The Industrial Revolution accelerated this process dramatically. Steamships replaced sails, iron hulls replaced wood, and canals like Suez and Panama shortened journeys by weeks. Suddenly, global trade was not measured in months, but in days. Naval empires gave way to industrial powers, and the oceans remained the critical arteries of commerce. Today, shipping is so routine that we barely notice it. Yet, modern trade depends almost entirely on the sea. Container ships, those floating giants of steel, carry about 90% of global goods. They glide across oceans with staggering efficiency, stacked high with colorful boxes filled with everything from electronics to furniture to bananas. It is no exaggeration to say that the container ship is the unsung hero of globalization. Without them, supermarket shelves would look very bare indeed. These ships follow routes as regular as highways, forming invisible networks across the oceans. From Shanghai to Los Angeles, Rotterdam to Singapore, they link the great ports of the world. Every day, thousands of vessels move in quiet procession, their paths tracked by satellites, but unnoticed by most of us. They have made global trade so seamless that it feels natural even though it relies on one of the most complex logistical systems ever created. The sheer scale is astonishing. Some modern container ships are longer than 4 football fields and carry over 20,000 containers at once. A single voyage can deliver enough goods to supply entire nations with food, clothing, and electronics. Yet despite their size, they remain vulnerable to the sea's moods. The blockage of the Suez Canal in 2021 by the Ever Given showed just how much of the global economy depends on these vessels. For nearly a week, one ship stuck sideways in a canal delayed billions of dollars in trade, reminding the world that even in the 21st century, the oceans still command respect. Trade by sea is not only about goods, it also carries culture, ideas, and people. Just as Phoenician sailors once spread the alphabet, and Polynesian navigators shared their knowledge, modern seaborne trade spreads languages, cuisines, and technologies. Migrants travel across the waves, workers man the ships, and global culture continues to knit itself together. Oceans remain not just the carriers of cargo, but the conduits of connection. Looking at the long story of oceans and trade, one sees both continuity and change. The winds that carried spices millennia ago still blow, though now ships run on diesel engines rather than sails. The ports that once bustled with merchants still thrive, though their warehouses now handle containers instead of amphorae. The principle is unchanged. The sea binds humanity together. There is a poetic irony in this. The same oceans that once seemed to separate continents have always been the very thing that unites them. Waves have carried both goods and grief, opportunity and oppression. Yet through it all, the sea has been the great facilitator, the stage upon which economies and empires have risen and fallen. When you next pick up a piece of fruit out of season or unwrap a package shipped from halfway around the world, you're touching the latest chapter of a very old story. That object has traveled in the belly of a ship across the restless sea, guided by currents and technology that trace their origins back to ancient winds and ancient sailors. The oceans, in this sense, are not just the backdrop of trade. but its essence. They are the reason globalization exists, the reason cultures have mingled, and the reason humanity has always been bigger than its borders. The waves may be timeless, but the cargo they carry tells of constant change, of economies and societies shaped by the movement of goods across water. The oceans and trade are inseparable, and in their partnership lies one of the defining stories of our shared history. The ocean has always been a source of fascination. But turning that fascination into science is a surprisingly recent development. For much of history, the sea was simply too vast, too dangerous, and too unpredictable to study with precision. Sailors knew its moods and currents through experience. Poets captured its beauty in verse, but a systematic investigation of the ocean's depths did not begin until the 19th century. Since then, oceanography has grown into one of the most dynamic sciences on Earth, combining ships, satellites, robots, and mathematics to unravel the mysteries of the deep. A turning point came with the voyage of HMS Challenger in the 1870s. This former warship was stripped of its guns and outfitted with laboratories, dredging equipment and sounding lines, transforming it into the first dedicated oceanographic vessel. For nearly 4 years, it sailed the globe, covering more than 70,000 miles and stopping at hundreds of stations to collect samples. Scientists measured temperature, salinity, and depth, dredged the seafloor for specimens, and lowered nets into the abyss. By the end of the journey, they had cataloged thousands of new species and produced charts that for the first time hinted at the scale of ocean basins. The Challenger expedition is often called the birth of modern oceanography, a moment when curiosity began to be paired with rigorous data. Mapping the seafloor remained one of the great challenges. For centuries, sailors had little idea of what lay beneath them, imagining flat plains or bottomless pits. The invention of sonar in the 20th century changed everything. By sending sound waves downward and recording their echoes, researchers began to sketch the contours of the ocean floor. What emerged was a revelation. Vast mountain ranges like the Mid-Atlantic Ridge, trenches deeper than Everest is tall, and abyssal plains, stretching for thousands of kilometers. The seafloor turned out to be as varied and dramatic as any landscape on land, only hidden beneath kilometers of water. Today, satellites extend this mapping even further. They cannot see the seafloor directly, but they measure minute variations in sea surface height caused by underwater features. A submerged mountain, for instance, exerts a slight gravitational pull that raises the water above it by a few centimeters. From space, those tiny bulges can be detected, allowing scientists to infer the shape of the terrain below. Thanks to this method, we now have global maps of the seafloor, though much of it is still only roughly charted. In fact, we know the topography of Mars and the Moon in greater detail than the bottom of our own oceans, a reminder of how much remains to be explored. Oceanography, however, is not just about geography. It is about understanding the processes that make the sea a living system. Currents, for example, are studied with a combination of buoys, floats, and computer models. Instruments drift with the flow, sending back data on temperature, salinity, and velocity. These records reveal the great conveyor belt of thermal circulation that links the oceans together, moving heat and nutrients around the globe. This circulation influences everything from monsoons in Asia to storms in the Atlantic, tying local weather to planetary-scale flows of water. Climate science and oceanography are now inseparable. The oceans absorb about 90% of the excess heat trapped by greenhouse gases, making them the planet's primary buffer against rapid warming. They also take in vast amounts of carbon dioxide, altering their chemistry in ways that ripple through ecosystems. Tracking these changes requires fleets of instruments, satellites monitoring sea surface temperature and height, drifting floats recording conditions in the depths, and ships deploying sensors across strategic regions. The result is a global ocean observing system, a kind of stethoscope pressed against the planet's blue heart. Modern research vessels continue the tradition of the Challenger, though they are far more sophisticated. Ships like the RRS Discovery or the Joy D's Resolution carry laboratories, drilling rigs, and sonar systems capable of mapping the seabed in exquisite detail. They can lower remotely operated vehicles into trenches, collect cores of sediment millions of years old, and deploy arrays of instruments to measure currents across entire ocean basins. These vessels are floating universities where teams of scientists live and work for weeks at a time, studying the sea in the ways that were unimaginable only a century ago. Autonomous technology has expanded the reach of oceanography even further. Gliders shaped like small torpedoes with wings drift silently through the water, adjusting their buoyancy to rise and sink while sensors record salinity, temperature, and oxygen levels. Some can travel for thousands of kilometers without returning to port, sending their data back via satellite. Remotely operated vehicles tethered to ships carry cameras and robotic arms to depths far beyond what divers could ever reach. They have filmed hydrothermal vents, recovered samples from trenches, and discovered countless species never before seen. These machines extend human senses into realms that would otherwise remain beyond our reach. Oceanography also depends heavily on collaboration. No single nation can claim to study the oceans alone, for the seas ignore political borders. International programs coordinate fleets of ships and networks of sensors, sharing data that is vital for understanding global phenomena. The Argo program, for example, maintains a fleet of thousands of robotic floats drifting throughout the world's oceans, each surfacing periodically to beam back measurements. Together, they form a global picture of the ocean's interior, something that would have been unthinkable even a generation ago. The science of the sea is not only about practical data. It also carries a sense of wonder. Every expedition has the chance to discover something unexpected, whether it is a new species, a geological oddity, or an unexplained phenomenon. In the 1970s, hydrothermal vents were discovered along mid-ocean ridges, complete with ecosystems powered not by sunlight but by chemical energy. More recently, deep-sea cameras have captured colossal squid, bizarre jellyfish, and landscapes of frozen methane. Each discovery reminds us that even after centuries of exploration, the oceans remain one of the last great frontiers on Earth. There is also a playful side to oceanography. Scientists sometimes give whimsical names to the creatures they find or jokingly refer to gliders as sea robots, and who could blame them? After weeks aboard a rolling ship, joy can be found in the smallest things. Whether it is spotting bioluminescence sparkling in the wake or lowering a camera into a place no human eyes have ever seen. The seriousness of the data is balanced by the sheer delight of discovery. Oceanography has come a long way since sailors lowered ropes with lead weights into the depths to measure fathoms. Today, satellites orbit the Earth, robots glide through the sea, and supercomputers model the flows of entire basins. Yet the essence remains the same: a desire to understand the vast, restless waters that cover our world. It is a science born of curiosity, sustained by technology, and driven by the recognition that the ocean is not just a backdrop to life, but its central stage. To study the ocean is to study ourselves, for our climate, our food, and our future are all bound to its rhythms. The science of the sea reveals patterns that are at once ancient and immediate, helping us see the planet as a connected system. Every chart, every measurement, every new species catalogued is another step toward appreciating the oceans not just as scenery, but as the living engine of the earth. And perhaps the greatest discovery of all is that for all our progress, the sea still holds more questions than answers, inviting us to keep exploring. The oceans, vast and seemingly eternal, can feel indestructible. Standing on a shore, it is difficult to imagine that something so immense could ever be vulnerable. Waves crash, tides rise, and storms sweep the water into towering walls of spray. Surely nothing could touch such power. And yet, for all their strength, the oceans are under strain. They remain resilient. But human activity has placed them under a pressure unlike any they have ever faced before. One of the greatest challenges is overfishing. For thousands of years, the sea provided food in abundance. Coastal communities lived from its bounty, pulling nets heavy with fish, trusting that the stocks would always replenish themselves. For a long time, this was true. But with the advent of industrial fishing in the 20th century, the scale of harvest changed dramatically. Massive trawlers now sweep entire sections of seabed in a single pass. Long lines stretch for kilometers, with thousands of hooks baited for tuna, swordfish, and sharks. The result has been dramatic declines in populations that once seemed inexhaustible. Atlantic cod, once so numerous that sailors claimed you could walk across their backs, collapsed to a fraction of their former numbers in the late 20th century. Bluefin tuna, a majestic predator capable of crossing oceans, has been driven to the edge in many regions by demand for sushi and sashimi. Overfishing not only threatens individual species, but unravels entire ecosystems as the removal of top predators cascades down the food web. Another pressure comes from pollution, the less visible but equally pervasive enemy of the sea. Rivers carry fertilizers and pesticides from farmland into estuaries, creating vast dead zones where oxygen is depleted and little can survive. The Gulf of Mexico hosts one of the largest of these, a seasonal hypoxic zone that can stretch for tens of thousands of square kilometers. Industrial runoff, untreated sewage, and oil spills further compound the problem. Each pollutant may seem insignificant in isolation, but together they accumulate into an immense burden. Plastics, in particular, have become a symbol of modern pollution. Every year, millions of tons of plastic waste enter the oceans, carried by winds, rivers, and careless disposal. Some of it floats, forming gyres of debris like the Great Pacific Garbage Patch, a superfragment swirling in the currents. Some of it sinks, littering the seafloor, and much of it breaks into microplastics, tiny shards that infiltrate the bodies of fish, birds, and even humans. Scientists have found plastic fibers in the deepest trenches in Antarctic sea ice. A reminder that no corner of the ocean is untouched. A plastic bottle discarded on a city street can eventually find its way into the stomach of a seabird thousands of kilometers away. Beyond pollution lies a subtler, but even more profound threat: acidification. When carbon dioxide dissolves into seawater, it forms carbonic acid, lowering the pH of the ocean. Since the Industrial Revolution, the oceans have absorbed about a third of all the carbon dioxide humans have emitted, acting as a vital buffer against climate change. But this service comes at a cost. The chemistry of seawater is shifting, making it harder for corals, mollusks, and plankton to build their calcium carbonate shells and skeletons. Entire ecosystems built on these organisms risk collapse if the trend continues. Coral reefs, already stressed by warming waters, are doubly threatened by acidification, their delicate frameworks dissolving in conditions that no amount of adaptation can easily overcome. Warming itself is another challenge. The oceans have absorbed about 90% of the excess heat from greenhouse gases, turning them into a planetary sponge for our emissions. This warming is uneven, but its effects ripple everywhere. Polar ice melts faster, raising sea levels. Marine species shift their ranges toward cooler waters, leaving traditional fishing grounds depleted. Heat waves in the sea, prolonged periods of unusually high temperatures, devastate kelp forests, seagrass meadows, and reefs. The Great Barrier Reef has suffered multiple mass bleaching events in recent decades, each one leaving large sections ghostly white, stripped of the vibrant corals that once flourished. The combined impact of these pressures is a loss of biodiversity on a staggering scale. Scientists warn that many marine species are at risk of extinction within the coming century if trends continue. Sharks, already targeted for their fins, reproduce so slowly that their populations struggle to recover. Sea turtles face gauntlets of fishing nets, habitat loss, and plastic ingestion. Even whales, once nearly wiped out by hunting, now contend with ship strikes, entanglement, and the gradual depletion of their food supply. Each loss diminishes not only the oceans, but also the balance of the Earth as a whole. And yet, for all this, the oceans show remarkable resilience. Areas placed under protection often recover more quickly than expected. With fish stocks rebounding and reefs beginning to heal, species adapt in surprising ways, shifting their breeding grounds, altering their migration routes, or finding new sources of food. The seas have endured ice ages, asteroid impacts, and climate swings far greater than those of human memory. Given the chance they can endure again, the key lies in whether we ease the pressures or continue to compound them. There is also humor, even in the seriousness of the situation. One could say that the container ship is the unsung hero of globalization. But plastics, its accidental sidekick, have become the ocean's unwanted guest. The irony is sharp. The very networks that bind the world together have also scattered our waste across every tide. It is a reminder that progress without foresight can quickly spill over into unintended consequences. To think of the oceans as both resilient and fragile is not a contradiction. It is the truth of life itself. They can absorb tremendous change, but not without limits. A reef can recover from a storm, but not from relentless bleaching. A fishery can rebound after a pause, but not if nets sweep it year after year without reprieve. The ocean can forgive, but it cannot be ignored. And when you stand by the shore and watch the waves roll in, it is easy to believe that they are eternal. In a sense, they are. The ocean itself will outlast us. But the richness within those waters, the shoals of fish, the gardens of coral, the whales that breach and the seabirds that dive, these are not guaranteed. They depend on choices, on restraint, and on recognition of how deeply our lives are tied to theirs. The threats facing the oceans are immense, but they are not insurmountable. With care, stewardship, and respect, the sea can remain what it has always been, the beating heart of the planet, powerful, mysterious, and alive. To forget that is to risk losing one of Earth's greatest treasures. To remember it is to see the ocean not as a victim, but as a partner, resilient, enduring, but deserving of our protection. When we think about the future of the oceans, it is tempting to picture them as timeless, unchanging blue expanses. After all, they have been here since the earliest days of Earth, shaping continents, nurturing life, and regulating climate. Yet the future of the oceans is not set in stone. It is being decided right now by choices both small and large. From the way we fish to the energy we use to the industries we permit. The seas, for all their depth and power, remain vulnerable to what happens above the waves. Their story is still unfolding, and humanity is one of the authors holding the pen. One of the most promising chapters in this story is the growth of conservation efforts around the world. Nations have begun to establish marine protected areas, sanctuaries where fishing is restricted, drilling is prohibited, and ecosystems are given a chance to breathe. These areas function like underwater national parks, offering safe havens for species to recover and habitats to regenerate. Studies show that within such protected zones, fish populations often rebound, corals heal, and biodiversity flourishes. The benefits even spill over into surrounding waters, replenishing fisheries and supporting communities. The scale of these efforts is increasing. Global initiatives such as the so-called 30 by 30 Pledge aim to protect 30% of the world's oceans by the year 2030. It is an ambitious goal, but one grounded in the recognition that without large-scale action, ecosystems may not withstand the pressures of overfishing, warming, and pollution. Already, places like the Papahanaumokuakea Marine National Monument in Hawaii and the Ross Sea Marine Protected Area near Antarctica demonstrate what is possible when protection is taken seriously. These vast reserves serve not only as conservation triumphs, but also as symbols of what humanity can achieve when cooperation is prioritized over exploitation. But conservation alone will not be enough. The oceans are intimately tied to the climate, and in the struggle against global warming, they are both frontline victims and vital allies. The seas absorb more than 90% of the excess heat trapped by greenhouse gases, buffering the atmosphere, but at the cost of rising temperatures and stressed ecosystems. They also take in about a third of our carbon dioxide emissions, altering their chemistry through acidification. If the oceans are to remain stable, they must be part of the solution as well as the problem. Scientists are exploring how the seas can help mitigate climate change. Coastal ecosystems such as mangroves, seagrasses, and salt marshes are champions of carbon storage, locking away vast amounts of blue carbon in their soils. Protecting and restoring these habitats could sequester millions of tons of carbon dioxide while also shielding coasts from storms and erosion. On the high seas, proposals exist for enhancing natural processes like plankton growth, which could draw more carbon into the depths. Such ideas remain controversial, for the ocean is a delicate system, and interventions can have unintended consequences. Yet the potential is undeniable. If treated wisely, the seas could help stabilize the very climate they now absorb the brunt of. Alongside these hopes, however, loom new dilemmas. Among the most pressing is the question of deep-sea mining. As demand for rare minerals grows, cobalt, nickel, manganese, and others used in batteries and electronics, companies are eyeing the abyssal plains where nodules of these metals lie scattered across the sediment. Mining them promises a supply of resources needed for renewable energy technologies. But the cost may be ecosystems that have taken millions of years to form. The deep sea, though seemingly barren, is home to unique life forms, many of which remain undiscovered. Disturbing these environments could have consequences we do not yet understand. Ethical questions swirl around this issue. Should humanity extract resources from places so poorly studied? Is the short-term gain worth the long-term risk? Some nations and organizations have called for a moratorium on deep-sea mining until more is known, while others push forward with exploration and pilot projects. It is a debate that encapsulates the broader challenge of our time: how to balance the need for progress with the responsibility of stewardship. Despite the threats and uncertainties, there are reasons for optimism. Advances in technology allow us to monitor and manage the oceans with greater precision than ever before. Satellites track sea surface temperatures and currents. Drones survey coral reefs, and autonomous gliders roam the depths collecting data. This wealth of information helps policymakers make informed decisions while also fostering a deeper understanding of how interconnected the oceans are with every aspect of life on land. The more we learn, the more we realize that protecting the seas is not optional. It is essential. Public awareness, too, is growing. Campaigns to reduce plastic waste, to eat seafood more sustainably, and to recognize the value of marine ecosystems have captured global attention. Schools teach children about coral reefs and climate change, while documentaries bring the beauty and fragility of the ocean into living rooms worldwide. This cultural shift matters because change often begins not in boardrooms or parliaments, but in the values of ordinary people who come to care about something greater than themselves. There is also a recognition that solutions must be cooperative. Fish do not respect national borders. Currents flow freely between countries, and climate change affects every coast. International agreements like the United Nations Convention on the Law of the Sea, while imperfect, provide a framework for shared responsibility. Recent treaties to protect biodiversity on the high seas mark an encouraging step toward global stewardship. In the future, such collaboration will only become more necessary. The ocean's story is far from finished. It is a tale of resilience, tested by pressure, of beauty threatened yet enduring. We know they have survived cataclysms before: ice ages, asteroid impacts, and shifts in chemistry far beyond our current influence. But we also know they are not invulnerable. The difference now is that the pace of change is faster, and the source of the strain is us. And so the question becomes, what role will we play in the next chapter? Will we continue to see the ocean as an inexhaustible resource, a dumping ground, and a frontier to exploit? Or will we recognize it as the heart of the Earth's system, deserving of protection, reverence, and care? The answer is not abstract. It is written in the choices made daily, in the policies governments enact, in the industry society supports, in the habits of individuals. Each decision is like a ripple spreading outward into the vastness of the sea. Alone, one ripple seems small, but together they shape the tide. To reflect on the future of the oceans is to acknowledge both uncertainty and possibility. The waves will continue to roll. The tides will continue to rise and fall. But the richness within them depends on what we do now. The seas are not silent. They speak through storms, through bleaching corals, through shifting fish stocks, and through rising coastlines. They are telling us that their story is being written quickly, and that our role in it matters. The ocean's future, like their surface, will never be still. It will be shaped by conflict and cooperation, by exploitation and preservation, by recklessness and wisdom. But within that uncertainty lies hope. For as long as people have lived beside the sea, they have drawn from it inspiration, sustenance, and meaning. If we choose carefully, that relationship can continue, not as a tale of loss, but as a story of renewal. The sea is waiting, vast and enduring, for the next words in its narrative. Whether those words are written in decline or in recovery is up to us. One thing is certain, the story of the oceans is not yet finished, and in its unfolding lies the fate of the world itself. The ocean story is in many ways the Earth story, from the first rains that cooled a fiery young planet to the ceaseless tides that continue today. The seas have been the backdrop, the stage, and the central character in the unfolding drama of life. They are the blue heart of the world, pumping heat, energy, and nutrients through its veins, shaping climates, carving coastlines, and giving rise to creatures of endless variety. To reflect on the oceans is to reflect on time itself, deep, patient, and unhurried. What makes the ocean so compelling is its paradoxical nature. It is constant yet always changing, familiar yet unfathomable, nurturing yet unforgiving. Waves arrive without fail, each one unique, each one repeating a pattern billions of years old. The sea can be a mirror of calm or a tempest of fury, yet in both faces it carries the same ancient rhythm. To sit by the shore is to feel part of something vast and enduring, a reminder that life's pace is fleeting compared to the sweep of geological time. Throughout history, people have looked to the ocean as both provider and mystery. It has been feared for its storms and revered for its bounty. It has served as highway, battlefield, and inspiration. Civilizations rose on its shores, traded across its surface, and drew their myths from its depths. Even now, in an age of satellites and sonar, much of it remains a realm of the unknown. The deep still resists our reach, keeping its secrets with a patience we can barely comprehend. And yet, for all its scale, the ocean connects intimately with our daily lives. The breath of plankton, drifting in the sunlit surface, provides oxygen for the air we inhale. The rise and fall of tides, governed by the moon's distant pull, shapes coasts and calendars. The warmth carried by currents dictates whether winters are mild or severe, whether rains arrive on time or fail to fall. To imagine the world without oceans is to imagine no world at all. The seas also teach us about resilience. They have endured asteroid impacts, ice ages, and the shifting of continents. Species have vanished, but life has always found a way to return, to adapt, to reinvent itself in forms both strange and wondrous. Even now, as the oceans face pressures from human hands, they show signs of recovery when given space to heal. Coral reefs can rebound, fish stocks can replenish, ecosystems can regenerate. The patience of the sea allows for renewal, if only we allow it. In contemplating the oceans, one begins to sense a rhythm larger than any single life. It is there in the tides that pull and release, in the migration of whales across hemispheres, in the centuries-long circulation of the global conveyor belt. The ocean moves in cycles of minutes and millennia, weaving together the fleeting and the eternal. It reminds us that while our concerns may feel urgent, the world moves at a pace far beyond our own, steady and unhurried. There is a quiet humility in standing at the edge of the sea. The horizon stretches unbroken, and for a moment the self seems small. Yet there is comfort in that smallness too, a reminder that we are part of something vast, something ancient, something that has been here long before us and will remain long after. The ocean does not ask for grandeur or attention. It simply continues wave after wave, tide after tide, as it has for billions of years. The oceans are also a mirror. In their reflective surface, we see our histories, our ambitions, and our vulnerabilities. They carry our ships and our stories, our commerce and our waste, our myths and our science. They reveal the best and worst of what humanity is capable of. generosity and exploitation, curiosity and recklessness. To look at the ocean is to look at ourselves, both the promise of what we can achieve and the caution of what we must avoid. As this long journey through the oceans draws to a close, it is worth pausing to return to the image of Earth as seen from space. From afar, our planet is not green or brown, but overwhelmingly blue. The seas dominate, wrapping continents in a shimmering cloak, reflecting sunlight into space, glowing softly in the dark of night. This view is a reminder that the ocean is not an accessory to the Earth. It is its essence. It is what makes this planet unique in the cosmos, what makes it habitable, what makes it home. And so the ocean remains timeless and patient. It will continue to surge against cliffs, to whisper against beaches, to breathe in rhythm with the moon. The tides will rise and fall long after our names are forgotten, long after cities have crumbled, long after mountains have eroded to plains. This endurance is not cold or indifferent, but quietly reassuring. Whatever storms we face, whatever changes unfold, the ocean will continue its eternal cycle, steady and true. Perhaps that is the greatest gift the ocean offers: perspective. To listen to its waves is to remember that time is vast, that resilience is real, and that connection is everywhere. Every droplet of rain, every breath of air, every grain of sand on the shore is tied to the sea. It is the link between past and future, between the smallest microbe and the largest whale, between distant continents and the lives lived upon them. As we leave this reflection, imagine the ocean not just as water, but as a living story being written. It is the memory of the Earth and its promise. It is the blue heart that beats beneath everything we know. To stand beside it is to stand beside patience, endurance, and quiet eternity. And as the day fades and night settles, remember this: the tide will rise again tomorrow, just as it has for billions of years, steady, eternal, and quietly carrying the story.